Okay, let's talk numbers. 500 hours of video uploaded to YouTube every single minute. Well, it's
It
staggering.
really is hard to wrap your head around.
Totally. And today, we're diving into how they actually manage that. How does it all work behind the curtain? This is kind of our backstage pass.
Yeah, it's a massive operation. When you think about it, from clicking upload to someone watching it, say, across the globe, there's so much involved. Ingestion, processing, storage, delivery.
It's complex.
Immensely. We've dug into how YouTube pulls this off the global scale.
Yeah.
It's pretty fascinating stuff.
All right, let's start right at the beginning. You hit the upload button on your video. What happens first?
Well, that video file on your device, it doesn't just fly over in one piece. It gets chopped up into 20 bits of data called IP packets.
Like sending a huge book page by page.
Exactly like that. These little packets travel over your Wi-Fi or mobile network, then zoom across the internet's highways to reach YouTube's big data centers. And naturally, things like your own internet speed, the file size, even how busy the network is, that all affects upload time.
Okay, so packets, not one giant file. I also read somewhere that creators actually have some choices during this upload.
They do, yeah. You can configure things. Like, you can tell YouTube to prepare for multiple byte rates right from the start, which helps later with smooth playback. Plus, setting privacy, titles, descriptions, all that happens then.
And for live stuff, like streaming.
Ah, right. For live video, they often use specific tech like RTMP or WebRTC. These are designed to get that video streamed to YouTube really efficiently with minimal delay. Super important for live broadcasts.
Gotcha. Okay, so the packets arrive, YouTube rebuilds the file, it's in. Now what? Does it get, processed? YouTube
Fied. YouTube-ified. I like that. Yes,
Yeah.
precisely. That's the processing stage. The raw video file you uploaded needs to be encoded. Think of it like taking a raw camera file and converting it so it can play easily on different devices.
Right. Compression and stuff.
Exactly. Compression is key. They use tools called codecs to make the file smaller without losing too much quality. YouTube recommends H.264, which is very common, and the newer, more efficient AV1 codec for video. For audio, usually AAC.
Okay.
But here's the really clever part. They don't just make one version. They create multiple copies of your video at various resolutions and byte rates. Everything from like a basic 360p version up to 4K or even 8K if you uploaded it that way.
Ah, okay. So that's why I see the little gear icon and can choose 1080p or 480p. Why make so many different versions, though? Seems like a lot of work.
It is, but it's crucial for a good viewing experience.
Yeah.
It enables something called adaptive byte rate streaming.
Adaptive byte rate. Okay, what's that?
It means the YouTube player on your device is smart. It constantly checks your internet connection speed. If your connection suddenly slows down, maybe you move to a spot with bad Wi-Fi, the player can automatically switch to a lower resolution video stream without interrupting playback.
Oh, okay. So instead of buffering.
Exactly. Instead of that annoying spinning wheel, you might just see the picture quality dip slightly for a moment, but the video keeps playing. Smoothness is the goal.
Makes sense. Okay, so we have all these different versions of every video. That must be an unbelievable amount of data. Where does it all live?
Yeah, the storage challenge is immense. It all lives inside Google's global network of data centers. These are massive, purpose-built facilities designed for exactly this kind of scale and reliability.
So just giant hard drives.
Well, yes and no. They use specialized systems. A lot of it is on what's called object storage, which is really good for handling huge numbers of large unstructured files like videos. And underneath that, they use distributed file systems. Google has its own, like GFS and Colossus, which basically spread the data across many, many servers for safety and quick access. If one server fails, the data is still safe elsewhere.
Right, redundancy. I think I also saw something about different types of storage, like faster and slower.
You did. That's tiered storage.
Yeah.
It's about efficiency and cost. Think about it. A viral video getting millions of views per hour needs to be accessed instantly. So that might live on really fast but more expensive solid-state drives, SSDs.
Okay.
But a video uploaded 5 years ago that only gets watched once a month, it doesn't need that super fast access. So it can be stored on more traditional cost-effective hard disk drives. It's about putting the data in the right place based on how popular it is.
Smart. Balancing act between speed and cost. Got it. But even if it's stored efficiently, how does that video get from a data center, maybe hundreds or thousands of miles away, to my laptop quickly when I press play?
Ah, that is the magic of the CDN, the Content Delivery Network.
CDN, right.
YouTube leverages Google's own massive global CDN infrastructure. Think of a CDN as a network of servers strategically placed all around the world, much closer to where users actually are.
Like mini YouTube caches everywhere.
Exactly. These CDN servers store caches, of popular videos. So when you in London hit play on a trending video, you're probably not pulling it all the way from a data center in the US. You're likely getting it from a CDN server maybe just a few miles away, in or near London.
Which makes it load way faster.
Much, much faster. It dramatically reduces latency and buffering.
Okay, incredible infrastructure. But with 500 hours a minute, not all of it is, cat videos. How do they handle things like copyright or content that breaks the rules?
Right, content management is another huge piece. For copyright, they have an automated system called Content ID. Copyright owners provide YouTube with their original audio or video files as references.
Okay.
Content ID then automatically scans basically everything being uploaded, looking for matches to these reference files.
And if it finds a match?
Then the copyright owner gets notified and has options. They can choose to block the uploaded video containing their content, they can allow it but run ads on it and collect the revenue that's monetization, or they can just track the video's analytics.
So it's automated detection and owner choice. What about harmful content? Stuff that violates YouTube's own community guidelines.
That's tackled through content moderation. It's a combination of automated systems and human reviewers. The automated tools use things like keyword filtering, image recognition, and machine learning models to flag content that might violate rules, hate speech, violence, etc.
Might violate.
Yeah, the automated systems aren't perfect. So flagged content, plus videos that users like you and me report, often get sent to human review teams located around the world. These teams watch the content and make a judgment based on the specific community guidelines.
Wow. Okay, so it's this constant flow, upload packets and code, multiple versions, store globally, distribute via CDN, scan for copyright, moderate, all happening simultaneously for hundreds of hours of video every minute.
It really is an engineering marvel when you break it down. The scale is just mind-boggling. Ingesting, processing, storing, delivering, keeping it all running smoothly 24/7.
It's incredible. So the next time you're watching absolutely anything on YouTube, maybe take a second to think about that journey. That video files trip from someone's camera through this massive global machine right to your screen.
Definitely gives you a new perspective.
It really makes you wonder, doesn't it? What does managing this kind of information flow mean for, well, the future of content and how these invisible systems shape what we see and experience online every day? Something to think about.
Absolutely.